All right, gentlemen. So, where were we? Page about 305, it looks like. We're going to go ahead and talk about evaporative emissions control systems. There were a couple of different ones, depending on what year, make, and model you have. At any rate, I'd just like to say, God bless the Lord, the coronavirus, and everything else. I'm out here sitting on my front porch talking to you guys. It's great. I love it. I really do, actually. And we're going to make some videos later today about how to troubleshoot some of this stuff. So you guys will be start getting up to speed on how this works. It's one thing to discuss it, which we have. It's a whole nother thing to go ahead and see it work. So that's what we're going to address. So we're going to talk about first. I'm going to shut off my phone because if you remember that, we got interrupted yesterday. There we go, airplane mode. Ta-da! Now everybody can suck my ass. Just kidding. We probably should edit that out, except I don't know how to do that, so too late. Anyway, okay, so here we go. So, so we talked about the fact that we lose 20% of emissions from the gas tank if we don't put pressure on it, right? So as a result, we went ahead and we pressurized the cap, and then we went ahead and we added a container, a charcoal canister, right, to save that. So what happens is, as the gasoline expands in the tank, as it gets warm, right, it generates vapor. So as it generates vapor, it goes ahead and it pushes it out of the tank and into the canister, another tank. Go figure. But the way it's stored in this media, it's stored more or less as a solid, right? It's almost liquid, is what it kind of boils down to. The beautiful part of that is that we bring in air through the vent. We go ahead and vaporize all of that again, and then we suck it up through the purge valve into the engine, and then the engine eats it. So we do actually have algorithms that test for whether or not that canister is loaded. So if the canister is loaded, it's not going to set codes for rich, is it, when the purge valve's on? That's not what it's designed to do. It's designed to purge those vapors, eat the vapors as part of its fuel. It can cut back injection pulse and move on with its job. So that's a fantastic thing. What can happen, though, is if we discussed, too, is if you overfill the tank and you get liquid in that canister, it can, A, ruin the canister. The other thing that can happen is that in unusual circumstances, but they do happen, if people keep filling it, you can actually get liquid through the purge valve and into the intake, in which case there's no way for the engine management system to really keep up with that much fuel. So at that point, it's going to choke. So once it chokes, it's going to set a rich code, and then it's going to have problems. So we discussed, let's discuss the simplicity of the design first. They're not really, let's see. I'm looking at page 305. And the way they've got this laid out, this is actually an advanced evap system on 305. Okay, so looking at this, it's actually taken from, yep. It looks like we're actually taking it from a generic source. So the reason I say that is because of the layout of the system. They show the air separator as the fresh air line into the canister over here on the left. They also show vacuum from the engine to a valve here, which will allow the vapors to come from the tank into the canister, which is not what we do now. We just simply allow the vapors to come in and hang out in the tank. And then they have the purge solenoid, but the purge solenoid is ahead of the diagnostic switch as far as if you backtrack from the throttle body to the tank. So I've never seen one configured that way. So I don't know if this is someone else's specific system and I haven't seen it, or if we're dealing with just a general picture. I'm not entirely certain. Usually what you'll see, this is an older style system. If you eliminate the diagnostic switch here and it has the vacuum from the engine to the top of the tank, okay, then this is actually a pre-96 system. Okay, so they send vacuum to that main line from the tank to the canister. They hold pressure in the tank initially. Then they let it go to the canister while the engine's running, and then the engine decides when to turn on the purge valve and when to go ahead and send that into the throttle body. So in that case, that's an older system. Why they put this diagnostic switch where they did, I have no idea. I can't tell you. It doesn't make a whole lot of sense because it's ahead of the purge valve. What I can say is that you can't test tank pressure this way, and you can't test. All you can test is flow. You can't test whether or not you're actually getting vacuum to the tank in this system. That doesn't work. Okay. The reason I say that is the placement of the switch. So, pardon me. So, obviously, if we get the vapors from the fuel tank into that canister and then through the purge valve solenoid up through the diagnostic switch to the throttle body, the only way, and the interesting thing is, of course, they put the switch there, but they've put absolutely no wiring there, so you have no idea. The computer has no idea either in this drawing that the system's even on. So that's perfect. It's wonderful. Good job. At any rate, yeah. Like I said, I've never seen one drawn this way. I've never seen one in real life this way, so I seriously doubt it even exists. Usually what they do is they put the purge valve in front of, and when I say in front of, I mean to the throttle body side of that diagnostic switch, and that diagnostic switch has two wires that run to the computer. So what happens is it sends out a 12-volt signal. You apply vacuum. It closes the switch because it provides a slight restriction. It closes the switch during flow. Then the computer sees that it's dropped low on the comparator circuit inside, and then it knows that it's actually purging when the purge valve is commanded on. Okay, that if you reverse those two switches, basically you're looking at a 96-97 Firebird. Okay, 96-97 Firebirds and Grand Prix didn't convert to the new system with the pressure sensor in the tank until the second half of 1997. So this is a hybrid system. It works, like I said, when the switches are reversed, when the switch and the purge solenoid are reversed. It does work to indicate flow or non-flow, but it's not helpful to know whether or not you're actually getting any negative pressure in the tank. So that's one of the keys why we went to the enhanced evap system, is to find out, do we actually get purge in the tank, and can we hold a vacuum on the tank? Because that's how we do diagnostics, right? So we talked about that a little bit previously as well. So let's turn the page and see what we have over here. Yeah, this is a much better picture, Chapter 306. This is the enhanced evap system. Now, I believe they said this came along later on in life. But we were seeing this on most cars in 1996. This is what they had already come up with. This is how they configured it. So you have a purge valve that opens it's normally closed. It opens to the throttle body and applies vacuum to the evaporative canister. The canister goes ahead and pulls vapors from the fuel tank, and it pulls in fresh air from the vent solenoid, which is normally open. So it pulls it in, goes through the canister, picks up the crud, and then heads up to the throttle body, in which case, ta-da, there you go, it knows that it's purging. And there are two ways it knows it purges, okay? Number one, the first way it knows it purges is because That's funny. We got cats inside that are playing around fighting. Anyway, the first way it knows is it watches the pressure sensor in the tank. So even if you don't shut the vent solenoid, you're going to have some negative pressure inside that fuel tank. And the reason you're going to have that, if you look at this drawing, okay, look at that, I can do this. The overhead viewer from my childhood. Anyway, the vent solenoid is going to bring in fresh air through here, through the canister, and then out through the purge valve and up to the throttle body. So what happens is, as it passes across this pipe from the tank, it forms a slight Venturi vacuum, right? Remember we did that with the cooling system filler, right? So as it passes across that, it forms a vacuum. It starts to pull a vacuum on the tank. So we do see some negative pressure in the tank while we're purging. It's not much, but it's a little bit. And anything below atmospheric, of course, is an indication that it's purging. Now, if it's not purging, if it doesn't see that negative pressure, if it doesn't see that negative pressure, then it assumes, hey, it's not purging, okay? And then it may set blocked evap vent path or what have you. It's going to run P0440 and 455. Those are technically the same code. It matters what gear car you have, whether or not it sets that code or something else, okay? So it's either going to set 440 or 455 for large evap leak. Now, 9 times out of 10, that's because the gas tank cap is loose and you can't pull a vacuum on the system because the kindly little old lady that brought it in forgot to put the damn thing back on. Happens all the time. The other possibility, and I will show you this when we get to the car, is that the cap doesn't actually tighten on the filler neck. Okay, I know I talked about it a little bit, where you hold the inside of the cap and you spin the outside of the cap with the handle, and presto, it just spins around like a pinwheel. So, at any rate, if you can't draw any sort of vacuum on the tank, it knows it's not purging. Okay. And then the other thing that it will do to make sure that it can pull from the tank is it will shut the vent solenoid. It will close it. Once it closes it, then the vacuum path goes back through the main line to the tank, and it will actually draw a vacuum on the tank. Now, we discussed the fact that cars usually test between 7 and 8 inches of mercury, right? And then we discussed the fact that the trucks test down to about 14 inches. That's gasoline only. We don't test diesels for evaporative emissions because, by and large, diesel doesn't evaporate. It takes it so long to evaporate, it's not considered important. The fuel is so heavy, it just doesn't go anywhere. So as a result, there is no pressure sensor in that tank. They don't care about that at all. There is no purge line or anything like that. It just doesn't exist. So the big leaks, okay, P0440, P0455, will be a leak down to 40 thousandths of an inch. Okay, small leaks, which are P0442, which are the ones that people really hate, but I'm going to teach you how to find, are down to 20 thousandths of an inch. Okay, now we've looked at that smoke machine, right? Now, if you hook up that smoke machine and you hook up the actual line to there are 2 orifices. There are actually 3 orifices, I believe, on the bottom of the tank. You can calibrate the little arrow on the flow gauge for 20 thousandths or 40 thousandths. There are orifices on the front of that. They're brass. You just screw them on. You press the button, turn it on, and then it will show you what the flow is supposed to be, what you're looking for. When you find that leak, it'll drop, right? Okay, I've never done that. I'll just say that right out, because that flow meter, for me, has never been super accurate. I do better with the smoke. And then visual inspection. I've solved a lot of things with visual inspection that even the smoke won't show me, because either the smoke doesn't travel there, or it doesn't travel there efficiently, or I'm in a hurry and it just makes more sense to do that. I have also used what's called an ultrasonic leak detector, and it's a set of headphones and a little box about the size of your cell phone. And then it's got a super sensitive microphone on it. So this thing, you hold it in your hand and you push the button, and then you move it, right, up and over the tank, and you move it over the line, over the purge valve. And when you hear it, it goes, right? Or you'll hear a bunch of white noise in your ears when you find the leak. So that's a great tool. What sucks is you can hear a fly poop at the other end of the shop with it. So if someone's using an impact, just put it back in the cabinet because you're not going to get anything out of it. That's the problem. It has to be so quiet to use that thing. It's almost worthless sometimes. So at any rate, so we've discussed this here too, the ORVR system, right? I believe that's at the bottom of the page right here, yes. So we're going to fill the tank, and then you'll notice that the vapors have to come up through this valve and then back to the filler neck, and that's what shuts off the pump. Okay, so there's your pressure control valve. So if the pressure control valve is messed up, or if the canister is restricted itself, then you're going to have one heck of a time filling that tank, because it's just going to immediately burp the pressure back to that nozzle, and it's going to shut the pump off. That's how it's designed to work. Okay, so we discussed the fact that we go ahead and we recover all the vapors now, and that's great, right? Remember we talked about the little shield over the pump that's supposed to keep the vapors in the neck. That was their first solution in California in the 80s, and it was decent. I'm not going to say it doesn't work, because if you fill up your car without one of those covers on the end of the nozzle, you can watch on an older system. You can watch the fuel vapors come right out of the nozzle, or the filler neck rather, around the nozzle, and just fall right down towards the ground and then evaporate into the air. You can watch that happen. It's pretty cool. So at any rate, is that good for the environment? No, not in any way, shape, or form. It is not. So we started using the ORVR, onboard refueling vapor recovery system, and it works really well. It does work really well. So let's see. We talked about that. So it says, let's see, ORVR has been mandated since '98. So that's that system, correct? But we've found on some vehicles that it depends on the weight of the vehicle, what emissions system applies to it. So on some of the heavier trucks, that didn't come along until later on, the 3/4 and 1 tons. Let's see. So they changed the filler neck, tank vent, canister, rollover check valve, all of that to make that happen. Okay. Let's see. So we have a fuel cap that actually works with vacuum and pressure relief. You remember we looked at those videos where those giant tankers went and crushed because the vent didn't work, right? So the same thing can happen to your fuel tank if the cap's no good. So a lot of times what I find is evaporative emissions failures are from the cap, but it's a vacuum failure, not a pressure failure, which sucks to find. So we're going to cover my rules of thumb and things like that on how to make that work, okay? So let's see. So we talked about all the one-way check valves and things like that to keep the vapor out of or the liquid out of the canister, right? We talked about that in class. And then we talked about the need to relieve the vacuum in the tank, otherwise the tank will crush itself. We discussed that before. You can see one of those ORVR canisters on page 308. And we talked to if you do happen to get liquid in there, it will ruin that canister, and that's a $200 to $300 repair just for the part. So make sure if you suspect that you have liquid in there, that you sell that canister. And usually you'll find it. If you just pull a line off of it, one of the purge lines or something like that, if people are complaining they're having a hard time filling up and this and that, and there's a bulletin to check the fill valve and all that stuff, right? So you check all that, maybe replace the filler neck, make sure you pull one of the purge lines, because if you don't pull the purge line from the canister, you won't find the liquid. But if there's liquid in there, you need to put a canister in it. That's very, very important. Because like we talked about, I'll turn it into a brick. Let's see. Yeah, so this is one of those things too. They made an author's note here, that the systems, that people think that the systems are completely sealed until they're purged, which is not true. Remember, we talked about the fact that the vent valve is open all of the time unless we close it for testing. But we rely on that charcoal canister. It's been redesigned, so we rely on that to catch all that fuel. So if you walk by your car on a hot day, do you smell fuel? You shouldn't. You shouldn't. If you do, you have another issue, and or maybe that charcoal canister has been flooded and it's full. So just keep that in mind. Let's see. So they give you some of the, on 308, they give you some of the parameters for running this purge test. What I'm going to go ahead, or running the purge valve in general, what I'm going to tell you is refer to service information. Okay. It will give you the conditions for running the test and the conditions for setting the DTC, what makes it fail, etc., etc. All of that information is going to be inside P0440, P0455, P0442, P0446, P1441, at least with General Motors. That one's a purge during non-flow, sort of a failure. And then if they give you P0441, some of them will, some won't, etc. So, also P0456. Especially in Toyotas, the canisters themselves have a vacuum pump on them, and they use that vacuum pump for diagnostics, and a lot of times that pump fails, or at least, and then in which case you just replace the entire canister. That's been my experience working on Pontiac Vibes, which is a Toyota Matrix, exact same car. They use the same tank and all that stuff on Corollas and everything else. So food for thought. Your mileage may vary, but always consult service information and bulletins. We actually had a bulletin for that code for those cars. Pardon me. That said, "You'll never find the leak. Just put a canister on it." That's what we did, and I didn't have any other issues with it. So you need to obviously check the integrity of the fuel cap, the purge valve, and the vent valve. My favorite way to do that is smoke. It's one of the quickest ways to find a compromised seal. The other thing too is that if I have an intermittent failure, which you will have occasionally, maybe more than occasionally, maybe you'll pull it in and it passes all the things that you do to it. But one of my favorites for caps is I'll just turn the cap over and see if the seal is cracked. If the seal's cracked, it automatically gets a cap. There's just no ifs, ands, or buts. And then I will test the system with the new cap. I won't even do that. So that's usually how I do that. And if it's just a cap, I mean, there are a lot of different theories on this, but I like to help customers. I believe that customers are our greatest asset and ally. And if they come in and say we're going to authorize $110 or $150 or whatever for you to perform diagnosis, and my first step, my first inspection shows me P0442, and I find that I have a cracked seal on a cap or it just spins, I'll go price that cap, and then I'll bring my labor up to the bottom end of what that cap costs. So if the cap costs $30, I'll charge 7/10. I'll charge a half an hour to check it, 2/10 to replace it. You're at the diagnostic fee, and then 9 times out of 10 it's fixed. So if that's the case, customers are really happy. They came in, they paid their diagnostic, the car was fixed for the diagnostic fee, and they're over the moon, and then you can sell them just about anything you want. you know, obviously there are people that are on fixed incomes and things like that, but that's been my experience, is that if they come in and you fix the car for the diagnostic fee and the car is 100% fixed, presto, they're more than happy with you, and they are ready to buy injection flushes and trans flushes and maintenance and things like that. So at any rate, that's my food for thought. If you want to charge them the hour and you want to charge them the cap and you want to charge them the 2/10 to change it, that's entirely up to you. Um, you know, like I said, it's, to me, it's easier, especially because if it's just a cap, the way I'm going to show you to do this, the entire diagnostic takes about 10 minutes. So if you do this entire diagnostic in 10 minutes and replace the cap and it's fixed, what have you lost? Really, you've already made money, even at 7/10. So at any rate, that's up to you. That's up to you guys, though. It's up to you guys. I have always erred on the side of caution. Anything I can't duplicate, unless I've spent 10 hours, you know, 4, 5, 6, 10 hours looking for it, I don't charge diagnosis. I don't want to own it when it comes back, you know, because then they'll come back and they'll go, well, ever since, and you charged me this and blah, 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 blah. Well, it's not worth it. It's not worth the argument with the customer. And it's very, very easy for you to help the service writer that way. And then the service writer can go, you know what, we didn't find anything today. The technician doesn't want to charge you at this time. He's cleared the codes, if there were codes, right? And you can't duplicate it. And then he wants you to bring it back when it's happening, if you can, right when the light comes on, et cetera, et cetera. And then, you know, if we can find something and duplicate it, we'll charge you then. Customers are usually very happy with that. So, and that's, to me, I've had a lot of people request me as a technician because I do that. So, at any rate, there you go. And like I said, it makes the service writers' lives a lot easier, and then they are much easier for you to work with, right? If they don't have to get in an argument for you to charge an hour, you know, their life is a lot easier. They have a lot of other fires to put out, a lot of other problems, and if you can't duplicate it, is it really worth them getting in a fight over? I don't think so, but it didn't. That's my personal opinion. Okay, so we also, let's see, and then they give you a picture here on 309 of the purge valve and how that gets activated by the ECM to purge the canisters out of that, or purge the canister and clear out all those vapors, right? Bullwinkle, shut up. Sorry, that's a dog. Somebody walked by. Yeah, you, shut your mouth. So, the other test that we talked about, right, was if you look at the second paragraph on page 309, the engine off natural vacuum test. So, remember we talked about how when you've driven the car and it's hot and then we shut the car off and we close that, the pressure will rise inside that tank and then it falls off again, doesn't it? Right? So in that calibrated window, if it doesn't rise high enough, it fails that test and it sets a small leak code. Ta-da, there you go. And then we discussed the fact too that 9 times out of 10, that failure is going to be a purge valve. That's been my experience at any rate. Purge valves are awesome for failing during that test. I have had them leak. I have had them leak in set 1441. That's not an unusual code. But on the newer stuff, especially on the newer LS engines, most of the time that leak is for a 442 and it fails the engine off natural vacuum test. It usually doesn't fail while the engine's running. It's usually temperature dependent is what I find. Okay, so let's see. Fuel tank level sensor. Well, we have to know how much fuel is in the tank to be able to calculate how much open space is in the tank because we don't fill it all the way, do we? So that makes a difference on how much pressure we're going to get on that ENOV test. So if the tank isn't between 15 and 85%, we don't even run the test. We don't even worry about it. So you could just tell your customer they don't want to see it, or if you don't want to see the light anymore, you just clear it and then you either run it with scrape in the bottom or you just keep it absolutely full all the time. So that's another option. Let's see, fuel pressure control valve. Okay, so that's about letting the pressure into the canister if it gets too high. Leak detection pump, that would be the vacuum pump that we talked about a little bit ago with the Toyotas. So there you go. And then they also put essentially, and I'm surprised they don't talk too much about it. Well, they do say that there's a fuel tank pressure sensor, and it monitors it for vacuum. Well, guess what? It also monitors it for pressure. So keep that in mind. That is effectively a MAP sensor, and it can read negative and positive pressure in the tank. It's a pressure transducer. Works on 5-volt signal and ground, just like a MAP sensor. And I will show you how you see that on the scan tool. Okay, so we talked about pre-combustion systems, and that would be engine design changes, PCV, ignition controls, EGR systems. And then we've changed the basic engine. We've got better sealing piston rings. They do seal better. The trouble is that the newer piston rings, as a rule, are low tension. So why do we say low tension, and what does that mean? So low tension means it doesn't grab the cylinder wall nearly as hard as the older rings did. So it's not as good at holding in compression. So why is that a problem? Well, it's a big problem. And the reason I say that is because you can't make everyone change their oil at 3,000 miles. And we've had that discussion as well. So what happens is it sprays the back of the piston, right, as it goes up and down the cylinder, and then it sludges the rings because the oil is so bad. Well, when that happens, the rings can't move outward anymore. And if they can't grip the cylinder, guess what? You lose compression. So if you lose compression, you lose power. If you lose power, you lose gas mileage, because you're going to have to make the engine work harder to take you the same distance, actually. Exactly. Let's see. Combustion chamber designs. Now, that's changed quite a bit, and we've seen some of that, right, with the direct injection stuff and how they changed the intake valve just a few degrees. Remember how it was coming down both sides of the valve and it swirled against it, and then the flame front wasn't the right, or it didn't expand as quickly, correct? And then it didn't burn as well. But we changed that intake valve, and then it flowed down over the top of it, swirled in the chamber, atomized everything, and then the burn was so much more even and so much quicker. So little changes like that make big differences, and they're always testing things like that. I was actually watching a video, interestingly enough, a while back on Ducati motorcycles, and the thing about gasoline engines is we're probably 95% developed as far as getting the most out of those engines. So Ducati was looking for, I can't remember, I think they were looking for 2 to 4 more horsepower, something like that. I mean, it was a minuscule amount. And they moved the intake valve 2 degrees, and they got where they were going, and they were just elated. That means they were very excited. So, and their reasoning was that they hadn't changed anything else. The rest of the engine was the same, the camshafts and everything else. So, big difference for just moving a valve 2 degrees. So there you go. Let's see, changes in compression ratios. Well, I mean, we're at a point now where and the other nice thing too on page 311 is they show you the quench areas. Okay, so if you look at the top of the piston, the cylinder walls, and the top of the combustion chamber, you'll see all the quench areas where the fuel comes in and it doesn't get completely burned, and that's why we want to swirl it and do all this fancy stuff with direct injection and everything else, right? And then inject it at a much higher pressure to make sure it stays atomized and it doesn't have a chance to fall out of suspension with the air, right? So that's I like that picture. That's a good picture. Changes in compression ratios, and of course we've talked about that and how if you move up in compression ratios, it's tougher to control emissions sometimes. But if you come up in compression ratios and you improve the cooling system and all of that kind of thing, and you start to control NOx with your variable valve timing and things like that, it is actually better for emissions because you get a more complete burn at a higher compression ratio because you're generating more heat. Right? There's less fuel in that quench area, especially if you're using direct injection and you're using it at 600 to 3,000 psi for gas engines. All right, so let's see. Faster computers, better timing control, direct fuel injection, variable valve timing, all of that really helps out. We talked about, improved cooling systems already. Decreased friction. Okay, so we talked about piston rings a little bit. Now, here's why they go to low tension rings. They go to low tension rings so that as you spin that engine, there are less parasitic losses on all of the cylinders where the pistons are moving up and down but not producing power. So for every power stroke, you have to move all those pistons up and down, but they're not contributing, right? They're coasting. So if they're coasting, right, then however much friction those rings give you in the cylinder as they go up and down, right, they can either grab on like this, da, 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 or they can go, and they can go, and really grind on that cylinder. The old rings, and then of course the high performance rings, the Moly rings, really, really grab onto the cylinders, and you will see some cylinder wear out of that. The new ones, you can pull a new LS down with 100,000 miles on it, and you'll still find crosshatch in the cylinder. That's how low tension the rings are. But that's also why the bulletins come out and say, hey, you know what? If your people are complaining about oil consumption, you may want to go ahead and pop those things out of there, replace the piston and ring assemblies, and then put them back in because the rings are just not holding the cylinder wall anymore. And GM has actually gone so far as to say, not only do you do that, you don't hone it. Now, they're saying if there's crosshatch left in that cylinder, those rings will seat and it will be fine. A couple different thoughts on that. If it were my truck, I would probably go ahead and hone it to give those rings a nice new place to bed. But I also know plenty of trucks that we've put pistons in and they run just fine, and it's never an issue again. Your mileage may vary. You do what you want. Old school dictates that you hone the cylinders. New school says you don't have to as long as there's crosshatch available.